Hi, I'm Jacob Brown.
Britton, Corbett.
I'm Austin Probasco.
I'm Christian Ramos.
Our project idea is outfitting the scuttle with a turret system and a retrieval system. The scuttle will be controlled by a user using a controller to move around and shoot projectiles. Once all the projectiles have been shot, the robot will enter recovery mode and autonomously find the projectiles and use a vacuum to retrieve them and place them back into the hopper so that it can be shot again.
The mission statement for this project is to create a scuttle robot that is able to shoot colored ping pong balls as projectiles and then use sensors to determine where the ping pong balls are and collect them. So this demonstration would first start by allowing user control through the gamepad controller to shoot and drive around the robot until the balls are empty from the hopper. So after it's been determined that all the projectiles have been fired or that the hopper is empty, the robot will then enter an automated state where it will use the sensors and information gathered by the sensors to drive around the room and find the ping pong balls and collect them. So the demonstration will end by either two circumstances. The first is a failure mode, which, for example, would be if after driving around for a specified time, the robot's not able to find a ball, it will enter a failure mode and then require user input. Or it'll end by after collecting all the balls and go back into user input mode where it will then be ended. And so our two methods of sensing are a LiDAR sensor will be used to detect the nearest object so that the robot can reorient itself in the right direction. And a camera will then be used to detect the color of the color of the object to determine if it's supposed to be retrieved.
So the scuttle robot's going to have four things for the actuation. We're going to have motor control for the scuttle wheels. We're going to have motor control for the ball launcher. We're going to have a vacuum air pump to pick up the ball/paper. And we're going to have a servo motor in order to load the balls to be fired. For data collection, our robot's going to keep a running tally of how many ping pong balls are loaded in the system at any given time. This is going to be achieved by using a counter after each successful retrieval. When the counter reaches 0, the robot begins searching for the ping pong balls, and once the counter displays a full capacity, the control will be given back to the user.
So the robot will have two routines that it'll run through. As mentioned earlier, in the first state, the user will be able to drive the robot using the controller and fire the projectiles. The robot will remain in this state until it either runs out of projectiles or the user initiates a transition to the second state using a button on the controller. In the second state, the robot will autonomously navigate the area and retrieve the projectiles using the vacuum. Once the robot has retrieved all of the projectiles, it will return to the first state. The robot also has two failure modes. The first, it will enter the first failure mode when it can't find any balls in the room after a certain amount of time, and it'll notify the user using lights. In the second mode, if the robot gets stuck and doesn't move for 30 seconds, it will go into a panic mode and call for a user to help it out, also using lights.